This is the gas law lesson 10.2, and this is question number 2 on the worksheet. The problem says, what is the temperature of a sample of chlorine gas if 0.75 moles of gas are collected at 115.2 kPa of pressure and the gas occupies 16.5 liters? The first thing I'm going to do is to go through the text and mark the variables that I recognize. So first of all, we see that temperature is mentioned right here. And then whenever we see moles, we know that's N. And then 115.2 kPa is the pressure. We haven't used kPa much, so you might not recognize that right away. And then, of course, liters would be volume. All right, so then what I did next was I took those numbers and attached them to the variables. Since we're using the ideal gas law, PV equals nRT, we need the value for R, which is a constant. And on your worksheet, I forgot to write in the 0.0821, so make sure you write that number in. And then I took all these values from the problem and I wrote them in the margin. Okay, you'll notice that there's two numbers for pressure. That's because the R value contains the pressure unit ATM. And so to get all of our units to cancel correctly, we need to make sure that our pressure is in atmospheres. And that's actually part B of the question here. So let's do that first. Let's convert 115.2 kilopascals or kPas into atmospheres. We'll use dimensional analysis, and if we go back on our notes, we see that 1 atmosphere is equal to 101.3 kilopascals. We need the kilopascals to cancel, so that's going to go on the bottom. And then 1 atmosphere goes on the top. So that cancels, and what we end up with is 1.137 atmospheres. Notice I kept the same number of significant figures that I started with. And it makes sense because 115.2 kilopascals is slightly larger than 101.3, and our answer, 1.137, is slightly larger than 1 ATM. So if we go back down here, you'll notice that I also wrote down the pressure in atmospheres. The first step in solving the problem is to write the equation, which I've already done. And then we need to rearrange it for the unknown variable or letter. Since we're trying to find temperature, I'm going to circle temperature, and then I need to divide both sides by whatever letters are on the same side as temperature. So let's divide by N, R, and if I do it on the right, I have to do it on the left. N will cancel, R will cancel, and that leaves T alone on the right side of the equation. So PV, doesn't look like a V, hang on here, over NR is equal to T. All right, the next step then is to plug the numbers or the values in. And I'm actually going to just flip this equation so that T is on the left and PV over NR are on the right. So let's start with T. And if I look at my list, I see that pressure is 1.137 atmospheres. I want to multiply that times volume, and the volume is 16.5 liters. And then I'm going to divide that by the number of moles, which is 0.75 moles, and multiply it times R. And if we go back up to our R value, the R value is 0.0821. The units are a fraction though, and I don't like to divide by fractions. So I'm going to take those units and multiply the reciprocal of the units times my fraction here. So let's go back up and just look at this again. So it's liters times atmospheres divided by moles times Kelvin. So if I want to multiply times the reciprocal, I'm going to multiply it times moles times Kelvin and divide by liters times atmospheres. And then when I go to cancel my units, it's a whole lot easier. So let's go ahead and do that. All right, so we've got atmospheres on the top, atmospheres on the bottom. We have liters on the top, liters on the bottom, moles on the top, moles on the bottom. So the only unit that we're left with is K, which is a temperature unit. All right, the next step then is to go ahead and put these numbers into the calculator. And we've got a couple of ways that we can do this. The way that I see students do it the most often is to multiply 1.137 times 16.5, and that would be 18.7605, and then divide it by 0.075 times 0.0821, and that product is 0.061575. Notice how I keep as many numbers as I can while I'm doing the math, and I'm not going to round until I get to the end. All right, so plugging that into the calculator is 304, and kelvins are the unit. The other way you can do this, of course, is to multiply the two top numbers, and then if you have parentheses on your calculator, you can divide by the product of the bottom numbers if you put it into parentheses. All right, so we've got one more thing to talk about, and that is significant figures. As we look back at the significant figures, we see that N only has two significant figures. Volume had 3, pressure had actually 4. And so since we only have two significant figures in our moles, we can only keep 2 in our answer. So at this point, I would allow you to keep 304, even though that's 3 significant figures, because the problem is if we round that to, try to round it to 2 significant figures, we get 300, which is technically 1 significant figure. So the only way to write 304 with 2 significant figures is to do it with scientific notation, which would be 3.0 times 10 to the second. Another way to handle this would be to go ahead and convert it back to degrees Celsius. So if we took 304 and subtracted 273, we get 31 degrees Celsius, and that's 2 significant figures. So we could go that route. But like I said, for this particular answer, if you kept 304 kelvins, that's okay too.